आज इस वीडियो लेक्चर में हम AKBB क्लास 10th एग्जामिनेशन अप्रैल में 2017 मैथमेटिक्स पेपर 1 को सॉल्व करेंगे. सो लेट्स सी व्हाट वी हैव इन क्वेश्चन नंबर 1. So here we have question number 1, and in this question we have to find the HCF of these two factors. So let's make the factor of these terms. So the factor of this first term would be 3 into x plus 5 and x plus 5. The factor of the next expression would be 3 into 5 and x plus 5. So the highest common factor would be the common among these two expressions. So we have 3 and we have 3 common and we have x plus 5 common. So our HCF for this question or these two expressions would be 3 and x plus 5. So the correct option in our question number 1 is option D, 3 into x plus 5. Next, we have question number 2, and in question number 2, we have to simplify this expression and express this into the simplified form. AB plus B square into A plus B whole square. So let's take common from numerator. So we will get A plus B in the numerator and A plus B whole square in denominator. So a plus b and 1 a plus b from denominator will be cancelled out. So the remaining or remainder we will get b over a plus b. So this is a correct answer that is present in option C. So correct answer for this question number 2 is option C. Next, we have question number 3. And for this question, we have to find the square root of this expression. So, this expression actually seems like the perfect square. So, let's check this if it is a perfect square. So, for the first term, it is the whole square, and similarly, last term is also a perfect square. So let's check the middle term 2 into A and B. The value of A we have in the first bracket, that is x, and the value of B is in our last bracket, that is 1 over A. So with the simplification we will get 2x over A that we have present in this middle term. So that's sure that this is sure that this expression is perfect square that is equal to x minus 1 over a whole square. So if we take the square root of this expression, so we will get x minus 1 over a. So in question number 3, the correct answer we have is option B, that is x minus 1 over a. Let's see question number 4. And in this question, we have to break this expression into the partial fractions. So 5x plus 3 over x minus 2 and x plus 3. As we can see that we have a linear factor and we have non-repeated linear factor. So the simple partial fraction for this fractional expression is we will introduce two constants with these two linear factors, non-repeated linear factors. So a over x minus 2 and b over x plus 3. So this is the correct partial fraction for the given rational expression. So the correct option we have is in option a over x minus 2 and b over x minus 3. Let's move to our question number 5. And in question number 5, we have to find the solution set of this equation where x over 3 minus b is equal to 0. So let's take this minus b on the right hand side of the equation. X over 3 will be equal to b, and 3 will be multiplied by b. So x would become 3b. So in question number 5, we have our correct answer, that is option C. So let's see question number 6. And in this question, again, we have to find the solution set of square root x plus 2 over 2 is equal to 0. So this 2 will be multiplied on the other side of the equation, that would become 0. So x plus 2 is equal to 0. Taking a square root on both sides of the equation, so square root and this square would be cancel out with each other. So we will get x plus 2 is equal to 0. So finally x will be equal to minus 2. So this is a correct answer, that is x equals to minus 2. And the correct option we have is option C. Let's move to the next question, that is question number 7. And in this question, we have to find the equation that represent the given situation. 2 times our number x reduced by 3. So 2 times means we have to multiply our number, that is x. So 2 times number would become 2x. Reduced by 3 means we have to subtract this number with 3, and the result would be equal to 5. So this is the correct mathematical algebraic equation for this given situation. So the correct answer we have is in option B, 2x minus 3 equals 5. So quickly let's move to the question number 8. And in this question number 8, we have an inequality with the modulus, and we have to represent this on our number line. So the modulus of x is less than 1, where x belongs to the real number. And we have to actually uh, represent this solution set on a number line. So let's expand this modulus. So the x would be less than 1 and x would be greater than minus 1. Whenever we reduce this, or whenever we remove this modulus, so this is always expanded with two expressions. One is in positive and the other is in negative. Simultaneously, when we expand this in negative real number, so the side of this inequality is reverses. So this is our answer, that x is less than 1 and x is greater than minus 1. So the correct option we have is option A, that represent x greater than minus 1 and x is less than plus 1. Remaining options in question option B, this equation represent that x is greater than or equal to minus 1 and x is less than or equal to plus 1. So this is the incorrect one. This equation represent that x is less than minus 1 and x is greater than plus 1. Similarly, this equation represent the option C, we have less than equal to and greater than equal to. This is x less than minus 1 and this is x is greater than plus 1. So obviously we have the correct answer as we have already selected, that is option A. So let's see question number 9, in which we have a linear equation 2x plus 3y equals 6. We have to find the missing value in this table, and in this table we have the value of y and we have to find the value of x. At x is equals to 2, this table represent that y x equals to 0, y is 2, and we have to find the value of x when y is equals to 4. So let's take this equation 2x plus 3y equals to 6. and we have to find the value of x. So let's replace the value of y that is given equals to 4. So 4 into 3 would be 12. So equation would become 2x plus 12 equals to 6. So this 12 will be subtracted on the other side of the equation. So that would become 6 minus 12. So 2x would be equals to minus 6. X would be equal to minus 6 over 2. So finally we will have x equals to minus 3. So the correct answer for this question number 9 is option B. So let's see question number 10. And in this question, we have a graph of the linear equations. And the equation we have is y equals to 3x. And we have to identify that which equation represent this type of graph. So this graph shows that, as we can see, that this is passing through origin, and this is the parallel to x-axis, and this equation passes through x-axis as well as y-axis, and this equation also passes through x-axis and y-axis. The type of equation that represent y is equals to mx, in which there is no constant number present. So this is the this type of equation, y is equals to 3x. There is no constant number in this equation. So this type of equation represents that this equation passes through the origin, and as we can substitute x is equals to 0, the value of y would be equal to 0. So one of the order pair that satisfy this equation y is equals to 3x is 0 comma 0, that we called an origin point. So among these four graphs, we can see that the option B is the graph that passes through the origin. So obviously the correct answer for this question number 10 is option B. So let's see question number 11 now. And in question number 11, we have two order pair that are equal. So A minus 2, comma, B minus 3 is equals to minus 2, comma, minus 3. So if these two order pairs are equal, then obviously abscissa will be equal to this abscissa, and this ordinate would be equal to ordinate. So from this given options, we have to give the value of A and B. So let's equate these terms. A minus 2 would be equals to minus 2, and B minus 3 would be equals to minus 3. So this minus 2 will move towards the right side, and this minus 3 would move to the right side. So A would be equals to minus 2 plus 2, and B will be equal to minus 3 plus 3. So the value of A and B we will get equals to 0, and B is equals to 0. So correct option in question number 11 we have is option A. So here we have the correct answer for this question, option A. Next, we have question number 12, and in this question, we have to represent this quadratic equation in our standard form. So, the quadratic equation we have is 3 over 2 plus x square equals to 2x. So, let's take the LCM on the left hand side of the equation. 3x plus 3 over 2 plus x square is equals to 2x. Or sorry, we can take the LCM, 3 2 would become the LCM, and 2x square in the other side, and we equals to 2x. So 3 plus 2x square would be equals to 4x. This 2 is multiplied on the other side, and let's take this 4x on the left hand side. So 2x square minus 4x plus 3 would be equal to 0. So question number 12, we have correct option, that is in option D. 2x square minus 4x plus 3 equals to 0. Next, we have our question number 13, and we have to find a solution set of this equation. So, The solution set of this quadratic equation x square equals to minus 1 over 2, where x belongs to the real number. So as we can see that square of this number is minus 1 over 2, and this is obvious that square of any number or square of any real number is always positive. किसी भी रियल नंबर का जो स्क्वायर है दैट कैन नॉट बी नेगेटिव, हमेशा रियल नंबर का स्क्वायर हमेशा पॉजिटिव आता है. सो दिस द वैल्यू ऑफ एक्स, वी कैन नॉट हैव एनी वैल्यू ऑफ एक्स दैट इज रियल नंबर एंड उसका स्क्वायर हमारे पास नेगेटिव में आए. सो दिस इज मैथमेटिकली नॉट पॉसिबल. सो if we take the square root over the both side of the equation, so x and root would be cancelled out. So x would be equals to 1 over root 2, and we will have the iota. So the value of x are imaginary iota we have in this value of x. So this means that there is no value of x that are real number that satisfy this equation. So the correct option we will have the empty set, and the reason why this is empty set I have explained here, that square of any number, any real number is always positive, and this in this equation the square is given as negative, so it's mean that the real number is not possible. The values of x would be imaginary. Next, we have question number 14. And in this question, we have to make this expression a perfect square. So let's make this a perfect square, x square plus 3x. So if first term is a perfect square, and we have to make this as the middle term of a square plus 2ab plus b square. So let's multiply this equation by expression by 2 and divide it by 2. So we can rearrange these terms as 2 and x and 3 over 2. So we have the two terms of this perfect square, and we need a b square. So b square would be 3 over 2 whole square. So this is the term that we should add in this expression so that this would become a perfect square. So the value of this term is 9 over 4. If we add 9 over 4 in this term, so this expression would become a perfect square. So in question number 14, we have option C, that is the correct answer. So let's move to the question number 15. And in this question, we have a diagram and we have to find the length of the segment AB. So this is a very simple question in which the we have 2 points, or we have 2 points, point A and point B. Both coordinates are given for these 2 point A and B. So let's apply the distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. So these are the values. Let's say this is x1, y1, and this is our x2, y2. So our expression will become 6 minus 0 square plus 8 minus 0 square. So 6 square plus 8 square, it would become 36 plus 64, and a square root of this will become 10. So option D we have is the correct answer for this question number 15. So let's see question number 16. In this question, we have a circle with center C, and the coordinates are 0, comma 0, and we have a point that lie on the edge of the circle that has a coordinate 1, comma 1. And we have to find the radius of the circle. So we know that the radius means the distance from the center to the point on the circle. So we have the center of the circle, we have the point on the circle. So let's assume this point as x1, y1, and this is x2, y2. So if we apply the distance formula, we will get 1 minus 0 square plus 1 minus 0 square. So we will get 1 square plus 1 square, that is 2. And correct answer in question number 16 we have is option C, square root of 2. Let's see the next question. Again, we have to apply the same concept, the distance between these 2 points. So let's say this is x1, y1, this is x2, and this is y2. Let's apply the formula as x2 minus x1 square plus y2 minus y1 square, and the square root of this expression. So this would become 3 square plus 1 square. So 3 square is 9 plus 1 10. So the distance between these 2 points is square root of 10. So in question number 17, the correct option we have is in option D. Next, we have the question number 18, and in this question, we have this value in the degree, and we have to convert this in DMS system. So let's convert this into DMS system, 53.25 degrees. So as we can see that before the decimal number, this is the whole part, that is 53 degree, and we have 0.25 degrees. So the conversion from degree into minutes, we multiply this expression by 60. So let's multiply this by 60 so that we can convert this into minutes. So 0.25 multiplied by 60 is equals to 15. So our question or expression would become 53 degrees and 15 minutes. So we do not have any decimal point in this value of minutes, so we don't need to convert further into seconds. So the value of seconds would be 0. So the correct option we have in question number 18 is option A, 53 degrees 15 minutes and 0 seconds. Next question we have is question number 19. And question number 19 states that in the fourth quadrant, which of the following trigonometric ratio is positive? So, among those four values, we have to find that which ratio has the positive value. So, in this topic, we have studied for a unit circle that x equals to cos theta, y equals to sine theta, and remaining ratios can be formed by using these two terms. So let's say we have this quadrant, and the question is talking about the fourth quadrant. So this is a fourth quadrant in which x is positive and y is negative. So this is negative x and this is positive y. So x sine theta is equal to y, positive y, and cos theta is equal to x. Tangent theta is equals to x over y, and the cotangent theta is equal to y over x. So sine theta is equals to y, and in fourth quadrant the y is negative. It's mean the sine theta would be negative. So this is the incorrect answer. Option D states that cot theta, and we know that cot theta is equals to y over x. So in the fourth quadrant, y is negative while x is positive. So this is negative, this is positive. The ratio we will have negative. So this is the incorrect one. Tangent theta is equals to x over y. So in the fourth quadrant, x is positive, y is negative, the ratio would become negative. So the correct option in question number 19 we have is option B, where B says that the cos theta is positive in the fourth quadrant. where as I stated that cos theta is equals to x. So x is positive in the fourth quadrant. So the value of theta, cos theta would be positive in the fourth quadrant. So we have a correct answer, that is option B. Let's see question number 20. And in question number 20, we have to simplify this expression. So let's apply the basic trigonometric identities on this expression where 1 plus 10 square theta over cos square theta. So we know that the value of 1 plus 10 square theta is equals to secant square theta. So if we substitute this in this expression, so we will get sec square theta over cos square theta. We can do one thing is that we can actually split this ratio like this: sec square theta multiplied by 1 over cos square theta. And we have studied the trigonometric formula that the reciprocal of cos square theta is equal to sec square theta. So we have this sec square theta, and we can replace this 1 over cos square theta by sec square theta. So finally we will get secant 4 theta. So this all expression is equals to secant 4 theta. So question number 20, the correct option we have is option D. So let's see our next question, that is question number 21. And in this question number 21, the a triangle is given, that is a right angle triangle at R, and we have to find the value of sine square theta. So we know that the ratio sine is equal to the side perpendicular to the hypotenuse. So theta is given in this expression. So side opposite to theta is perpendicular, and the side opposite to 90 is hypotenuse. So value of hypotenuse is r, while the value of perpendicular is p. So let's replace these expression. Value of p is p, and the value of hypotenuse is r. So if we square these sides, so that we can find the value of sine square theta. So p square over r square would be the ratio sine square theta. So in question number 21, the correct answer we have is option B, that p square over r square. Next we have question number 22. Sarah and Sajid visited a park which is rectangular in shape as given in the diagram. A tuck shop is located at a point A, and a coffee shop is located at point C. So this is our tuck shop, and this is the point of coffee shop. The shortest distance between the tuck shop and the coffee shop we have to find out. We know that shortest distance is always a straight line, so we have to actually measure the diagonal of this rectangle. So we have perpendicular side, we have base side. So let's apply the Pythagoras theorem to find the value of this x. So x square would be equals to 60 square plus 80 square. So 60 square would become 3600, and um 80 square would become 6400. So it 36,100 plus 6400 would become 10,000 equals to x square. So for the value of x, if we take the square root, so the value of x would become 100 meters. So the correct option in question number 22 we have is option B. Let's see our question number 23. In this given diagram, if the diameter of the circle is AB, so this as we can see that this triangle is a cyclic triangle all the points are lying on this circle. So the angle opposite to the diameter is always 90 degree. So we have 90 degree at this point, and we have to find the radius of circle in terms of A and B. So this is the side, that is the diameter or the hypotenuse of this right angle triangle. So the side AB square would be equals to A square plus B square. This is, let's say, perpendicular, and this is the side base. So AB, the value of AB would be equals to A square plus B square and a square root. We have applied the square root on the both side of the equation. So we have the value of AB, that is equal to diameter. So if we divide this diameter by 2, AB over 2, so we will get the radius of the circle, that is a square plus b square whole square root divided by 2. So in question number 23, correct option we have is option D, a square plus b square over 2. Let's see question number 24. And in this question, consider the given square ABCD and the length of the diagonal we have to calculate. So again, we will apply the Pythagoras theorem. We know that the sides of the squares are equal, so these two sides are equal to A. We have to find the value of this diagonal. So let's apply the Pythagoras theorem, because square in a square all the angles are equal to 90 degrees. So according to Pythagoras theorem, x square would be equals to a square plus a square. So x square would become 2a square. If we take root on the both side of the equation, x square would be equals to 2a square, and the square root on this, the value of x or bc would be equals to square root 2 times a square, and this square and root of this a will be cancelled out. So we have the correct answer, that is option C, square root 2a. Let's move to our question number 25 and 26. In question number 25, a circle has two chords of 5 centimeter and 3 centimeter. So we have two chords that lies at a distance of 7 centimeter and x centimeter respectively. So let's make a circle. So let's suppose this is our circle, and we have two chords that are 5 centimeter and 6 centimeter. So let's say this is the center of the circle, and this is the small chord. Let's say this is the small chord of length 5 centimeter, and this is the greater chord of 6 centimeter. So obviously the greater the chord, it would be nearer to the center of the circle. If the chord moves away from the center of the circle, it becomes shorter and shorter. So in the circle 5 and 6 centimeter, two chords of 5 centimeter and 6 centimeter that lies at the center of 7 centimeter and x centimeter respectively. So the distance of chord 5 centimeter is 7 centimeter, and the chord 6 centimeter lies at a distance of x. The distance of this chord is 7 centimeter. So as the theorem states that the greater the chord, it will be nearer to the center of the circle. So this chord is greater than 5 centimeter. This means that the distance of this chord from the center of the circle would be less than 7. So question number 25, the correct option is option A, that is less than 7. So, question number 26, the distance between two circles touching each other externally is 10 centimeter. So, we have two circles that are touching externally. So, here we have two circles with these are the center, and the distance between their center is given as 10 centimeter. And radius of the one circle is 7 centimeter. We have to find the radius of the other circle. So let's say this is the radius r and this is the radius small r. So according to the theorem, if two circles touching externally, the sum of their radii is equals to the distance between their centers. So if one circle is 7 centimeter, so the other would be obviously equals to 3 centimeters. So the correct option we have in question number 26 is option A. Let's see question number 27. In question number 27, if two circles touch each other externally and their radii are 8 centimeter and 12 centimeters, so we have to find the distance between their centers. So this is again the same type of question that we have solved in the above question, that was 26. So again, same concept is applied. Two circles that are touching externally, and let's say these radius are r and small r. So as I have stated earlier, the distance between their center is equals to the sum of radii r plus r. So 8 plus 12 would be equals to the distance between their centers. So the correct option in question number 27 we have is option B, that is 20 centimeters. So let's mark the correct answer and quickly move to the question number 27, 28. In this question, we have two congruent circles. The congruent circles mean the radii and the um diameters of both circles are equal, and we have two chords. One is the chord of 4 centimeter and one is the chord of 3 centimeter. So this chord is the greater one and this chord is the shorter one. As we know that shorter chord is near to the circle. This is the less distance, and the shorter chord is the farther away from the circle, and the greater chord is nearer to the circle. We have to check which of these above condition is correct, is or are correct. So the arc AB is less than the arc DE. AB arc is this one and DE arc is this one. So this is the greater chord, and greater chord means it will form the greater arc, while this chord is the smaller. This means that its minor arc will also be smaller. So this option condition is incorrect, because AB should be greater than the arc DE, because the chord formed by point AB is greater than the arc chord formed by the BDE. So let's check the option or condition number two. The major arc ACB. This is the major arc in the first circle. ACB is greater than the arc DEF, that is also a major arc. So the theorem states that uh, if the chord is longer, that is near to the circle, so the major arc would be smaller. If this chord is nearer to the circle, so this major arc would become smaller, and if this chord is smaller, then it will be away from the circle, and the major arc formed by this chord would be greater. So this condition number 2 is also incorrect. In condition number three, arc ACB, that is the greater arc or the major arc, and the arc DEF is also the major arc in the second circle. And this condition says that the major arc is smaller than the major arc of the um, corresponding congruent circle. So the arc ACB, in which the chord is 4, and the arc DEF, in which chord is 3. So greater the chord, it will be away from the circle. Sorry. The greater the chord, it will be towards the center of the circle, and the major arc will be smaller. And smaller the chord, as we can see in the second circle, smaller the chord, it will be further away from the center of the circle, and the major arc formed by that chord would be greater. So this condition is true in which the major arc in the first circle is less than the major arc in the second circle. So correct option in question number 28 we have is only third condition, that is true. So the option B we have is the correct answer. Let's move to the second last question of this paper. And in this paper, again, we have a theorem on the circle. In this given circle, having a center O, we have to find which of the following conditions are correct. So let's check the first condition, AOB. The angle AOB is measured as A. So let's say we have a chord formed by this points AB. AOB is the central angle and measurement angle DOC. Measurement angle DOC. This is also the central angle that is formed by the chord DC. So as we can see that these two angles are equal because these two angles are formed by the intersecting points of two straight lines. So the first condition is true. Let's check the second condition. The angle AOB that is marked with A in this central point is equal to the double of DEC. So DEC is the angle that is formed at that point. So let's say the value of DEC is 50 degrees. So the central angle of this angle E or DEC is formed at that point. So we know that the central angle is doubled or that of the angle at the major arc. So this would also be 50-degree, and we know that these opposite angles are the vertically opposite angles. So this would also be equal to 50-degree. So this condition is also true. Let's check the third condition. DOC is the central angle of the chord DC, and DEC is the this angle that is formed at the major arc. So this states that the central angle would be equal to half of the angle at the major arc. So this is the incorrect option because central angle is double of the angle formed at the major arc. So this condition is incorrect. So we have two conditions, that is 1 and 2. So the option C would be the correct answer for this question. So finally, let's move to our last question of this year, in which we have a circle with a cyclic quadrilateral in which 4 points of the quadrilateral lie on the circumference of the circle. So in this quadrilateral, we have the angle A that is 50-degree, and we have to find the angle C. So we know that angle A and angle C are the opposite angles in a cyclic quadrilateral, and the theorem states that the opposite angles of the cyclic quadrilaterals are supplementary. It means that the sum of these two angles would be equals to 180. So angle A plus angle C is equals to 180 degrees. So angle C would be equals to 130 degree. So question number 30, we have the correct option, that is 130 degrees.